Juan Medina, and today I'm going to be talking about the heartbeat bug. Just as a disclaimer, this is for educational purpose, and always make sure to get permission before using the or exploiting any system. The heartbeat bug, or CVE 2014-0160, is a severe implementation flaw in the OpenSSL library, which enables the attacker to steal data from the memory of the victim server. The contents of the stolen data depends on what there is in the memory of the server. It could potentially contain private keys, TLS session keys, username, passwords, credentials, credit cards. Uh, the vulnerability is implementation of the heartbeat protocol, which is used by the SSL TLS to keep the connection alive. This was found by Neil Mehta, which was a Google computer security employee, on March 21st, 2014. The extension to TLS Keep Alive is similar to ping. Therefore, it checks to see if there's a valid connection. The heartbeat request message can arrive almost at any time during the lifetime of a connection. If no response is received from the server within the particular time, a timer occurs. For every request a message is sent by client, the server has to answer that is sent a reply to client immediately. Implemented on 2012 by RFC 6520. The heartbeat blog was found by Neil Mehta. As you can see here, first, the way the bug works is the attacker sends some malicious heartbeat request to a vulnerable computer running OpenSSL. Then the request payload is written to memory, and then the response of 64K formulates a response that copies 64K data from the starting where it wrote the original request payload. The return 64K response includes the original request payload and whatever data is in the adjacent memory locations. Return data could contain encryption keys and other encrypted data. The heartbeat message is an open source that is used in OpenSSL. OpenSSL is a open source that is reading language which is used for SSL TSL protocol with heartbeat extension. The heartbeat protocol consists of their type, an arbitrary payload, and padding. The type is the message of the either a heartbeat request or a heartbeat response. The payload length is the length of the payload, and the payload consists of arbitrary content. The padding is the random content that must be ignored by the receiver. The sender of the heartbeat message must be random padding of at least 16 bytes, and the padding of the received heartbeat message must be ignored. If the payload length is received of the heartbeat message is too large, then the received heartbeat message must be discarded silently. Here you can see the processing of the malicious heartbeat request message. Here's the heartbeat request message at the beginning, where it's showing the read type and the payload length, which is the heartbeat request message. The heartbeat type, as you can see, is heartbeat type 1, which is a request. And here you can see the payload length, which is 65,535. The payload, which is bird, with some additional malicious code that will return in the heartbeat message. Here in the heartbeat response message, the heartbeat type is number 2, As you can see, the payload length is 65,535, and the message that it returns is bird, and the extra data that is extracted since it caused an overflow and retrieves from memory. Here, the HeartBleed bug source code, as you can see, it contains the content type, it contains the TLS version, it also has the length of the payload, as well as the payload itself with the initial bytes, and then some malicious content that would allow it to create a buffer overflow and extract extra data from the server. Here you could see where is asking if the heartbeat response was received, and it checks to see if it's vulnerable. If the heartbeat response shows to be vulnerable, then you can see that either it returns the key, and it also provides a hectop pay of the extra data that it could be extracted from the heartbeat. Now I'll show you a demonstration where here that you could see what a return data it shows vulnerable. You can see this. I'm gonna run it again now. Now this returns that there was a group created that was named Ballers. And finally, here's another running, and this is the final running where here it shows that there's a username con admin and the password is seed elg. So at this point you can see that we completely got complete access with the admin privileges for this using this vulnerability in the system. So the solutions for this, it was first is to make sure you update and patch your systems. OpenSSL 1.0.1G fixed the heartbeat bug on April 2014, and it made it as a default. The SSL3 structure will show the correct length of the payload, and if any one of the below conditions is true, then the server has to discard the message completely and silently. And thank you. And below are the references that I use for my research and exploit.